Telefónica is just a brief introduction. Telefónica is probably, it's a telco about the size of AT&T or Verizon. We are in about 15 countries, mostly 3 in Europe and the remainder in America, in Central America, Mexico, all the way to Argentina. A few years ago, we started toying with the idea that things had to change in the telco environment. We could no longer afford to maintain the big legacy equipment manufacturers, the black boxes and things like that. So in 2011, kind of lights turned up, and we found out that there was 3 concepts or 3 ingredients that we could put together and come with a wholly different concept of how we do central offices. Central offices today are full of monolithic equipment that does very particular functions, each of them, and then that way you can get internet to your house or video or TV or whatever you have. So we took advantage of 3 things. Cloud computing. OpenNebula is the main system we're using on this. SDN, software-defined networking, which was a venture of Google, Verizon, Nippon Telecom, Telegraph, plus Deutsche Telekom. They came up with a way of separating the control plane from the data plane with a standard protocol. And then NFV, which is network function virtualization. And that, for most of us that are from the IT world, virtualization came before cloud. But for the network people, network functions virtualization is a new thing, the new kid in the block, and there's a lot of effort being done with the major organizations that do standardization in the telco environment to kind of virtualize or separate the infrastructure from the functions of a network. Why did we want to do this? Well, 2 things. First of all, the complexity of the current systems adds a lot of latency to the data streams. And then IP came around, and we realized that we don't need most of the protocols that we do have today providing you service as an end user. And also the growth of the data consumption puts on the telcos a tremendous effort, especially with net neutrality. We find that the big boys, the Googles, the Amazons, they always talk about net neutrality. But when it comes to peering, it's very asymmetrical. We as a telco send a request for a video, and they as a video provider send you megabytes, sometimes gigabits of data. So it's not symmetrical, and we cannot keep providing that kind of service. That having not said, well, we are trying to leverage different technologies. Also, we need to, customers demand more and more from more and more services, better quality. And right now, we are trying to create unique experiences for the customers. And a unique experience could be how you manage your network in the house, how you watch TV patterns. Like right now, TV a la carte is very common. I don't watch TV live anymore. For several years, I don't do that. When I get home, I want to watch this football game, and I put it on. I don't know the results, so I enjoy it like if it was live, but I watch it on my own time. Same thing with the news and any program you want to. So this puts on Telefónica and most telcos a real challenge on being able to deliver content and to be constantly updating content at the rate that the end customers want. To give you an idea, we have all in all, about 300 million customers. So it's quite challenging if all of them today they can't, but if all of them today were able to watch TV on demand, you can imagine the pressure on the systems and on the networks that will put on us. So we have divided the network in 4 platforms, let's say. One is data analysis and big data and all these new things, and then we have the product and services platform, and then we have the IT platform, and then at the bottom is where we are. We're in the physical layer and on the content delivery layer. So what was the aim of the project? The aim of the project is, because we're right now, was last time I presented in Barcelona when they invited me to make a presentation. It was an idea. Now it's something that we're actually deploying in a pilot in Madrid. But we wanted to build programmable networks. We want to build networks that can really perform autonomous functions, and they become self-sufficient or self-reliant to a sense. And to do that, we need to separate, as I said before, the control plane from the data plane. Today, in a traditional network, each device providing a service has its own control plane, fully integrated to the data plane. So you can imagine, to control the different pieces, it takes a tremendous amount of labor and supervision work. You know, we have hundreds of people that just are continuously supervising the system and updating tables so we can route the traffic the best way. SDN allows us to move traffic and to create a new connectivity path if there's a physical failure, or if we find out that some elephant traffic is moving through the network. With SDN, we can move it in a different path to make sure it reaches its destination. What was the concept we built on? We said, okay, fine. Excuse me. If we really want to make an impact on Telefónica's networks, we got to go to the edge, to the access network. This is where we have to be. Today, up to today, there was a lot of effort put in the core network, make sure that the pipes were big enough and that we could push enough traffic. But we decided that we were going to go to the edge and turn the central office upside down and make it autonomous. So what you see here is the new concept of the central office. The central office will become a marketplace where you could have third-party services or Telefónica's own services, and we can host them directly on the central office. What is the big difference of what you perceive today? Well, today you have the main service providers, or OTTs, have maybe 40, 50. You know, Google is aiming to have 70 data centers. We at Telefónica are aiming to have hundreds of data centers, not just humongous data centers, but distributed data centers. So what is the idea? The idea is to bring the services today. The tendency is to centralize everything in huge data centers. That's been the tendency for years because infrastructure was expensive and it was hard to manage and to control. But using the three ingredients that I said, we're going to be able to manage to bring back the services to the edge, thus providing an ecosystem that is capable of providing services that today we have no idea that they don't exist yet, but we'll be prepared when they come. Augmented reality and augmented reality, autonomous vehicles, content delivery at a fast rate, video games that are today more and more demanding need to be very close to the edge, very close to the end user, so the end user experience is unique, and he feels like he has the computer power in his house or in his office. So what we did is we have created an architecture which allows us, as I said before, to host all these kind of services, and we can connect directly from the central office to big cloud providers. That could be AWS. We're working with them today to see they're interested on working with us on being able to provide capabilities at the edge. Azure, we're big users of Office 365, so they have a vested interest that our employees have a real good experience with Office 365, so this will help them. And we are also working with companies like QWield. We work with Akamai on the first phase. Niji is a product, it's a Telefónica product that allows content selection and filtering Navista is, for those of you that work with SD-WANs or any OTT service for big enterprise connectivity or campus connectivity, Navista is a product that allows us to do that. It's a third-party product that we put together. What was the idea? Well, you know, it's written right there. We were trying to do make sure that we can accommodate any product and service that comes to the market and that it organically grows as the demand grows. When you have a centralized network like we do, and you want to launch one of these products, you have to size it so all customers, all possible customers, could have access to the product. But it might be that the product doesn't take off, or the product, a region of the country wants to use that product more than another. You still have to size it. So for that, you know, if we do go to the edge, we can have flexibility and simplicity at the time we develop a new product or a third-party product. It's also a platform for innovation. The aim that Telefónica has is that we will create an ecosystem that will allow third-party companies, small and big, to bring products to their customers without on a fair level play field. Fair level play field with the big boys. Big boys are the ones that today really mandate what products and what products are not put into the network. Who have cloud resources, edge computing cloud resources. You're going to see what type of equipment we're using. Guarantee low latency, definitely. There is nobody between a telco and the end user. Nobody. If there was somebody, it would be a telco. So we are the first point of connection from your house to the internet, from your enterprise to the internet. We are the first and the only ones. If not, you know, you'll be called something different. So we can guarantee low latency. Our fiber optic networks in Spain have because the standard dictates so. The longest distance is 20 kilometers between the customer and the data center and the central office, and at 200,000 kilometers per second, because you know with the fiber optics we don't get the 300,000 kilometers per second light speed. We always get about 200 and some because of the interfaces and changeovers between electrical and optical. So we can guarantee. We cannot say it's going to be the lowest, but we can guarantee you that the latency will be the same all the time. And that is very important for people doing robotics and for people doing enhanced reality. As you know, most of you are from the academia world. As you move your head around, if the images don't follow the rate of turn of your head, you get immediately dizzy, because your head always knows. Even if you're unconscious, you know what's around you, and when you turn your head, you expect to see the curtain right here, even though I have never paid attention to the curtain, but it's there. If I turn my head and it's not there, then you get an immediate reaction. This is more of the reasons of why at the edge. I'm not going to go through all of them, but we can share the presentation with you at the end. That's no problem. We think that personalized services are a must. People tend to use the internet in many different ways. Families, individual persons, enterprises. You need to have an edge experience where you can really have a powerful computing engine behind you and not having to have it at your location, at your premises. This architecture that we are providing, it's a true fusion architecture. Once we go into the details, you're going to see how we're putting the fiber access network with the mobile access network with our enterprise network all together into one single entity. Truly open, we have used for this solution only open components. OpenNebula is the main system supporting the architecture, and then we're using another system for software-defined networking. It's a product from Berkeley and Stanford University's ON.Lab, and we think we're 5G ready. Whatever 5G will become to be at the end. We're using agile development, which Can you imagine in a telco that it is quite strange for us? We're used to life cycles of 36, 48, not days, not weeks, months. Because the legacy system manufacturers are, they don't like to change their technology that often because they have an invested product development cycle that they have to monetize. So we have done in the development, we're accelerating the times of bringing products to the market right now with the help of OpenNebula, virtual machines, and Ansible instantiation. We bring new products and new machines in about 2 to 3 days of integration, and then we use SDN to connect them and deliver the services. Deployments are quite easy. We're continuously deploying new versions. Here we're at launch time. We have changed a little bit the mindset of a telco, where we are allowing the product development people to develop an image of the product they want to instantiate, they want to sell, so they can test it. And once we get it into the central office, we can instantiate it and sell it. It's the same image that they created, so there is not these typical problems that network did this, IT did that, what I wanted was this. So here they'll have a chance to really put into production what they created. And the activation and keeping the thing running is quite easy when you're using cloud technologies, and we can really, the actual product catalog is the amount of images you have created, and you have it on your inventory. So there is no mismatch with what is on production, with what you think you have, and what's really being invoiced. Now going back to the main portion of the presentation in the last 10 minutes, let's see. The components we have deployed today are OpenNebula. OpenNebula manages all the infrastructure, and this is the SDN engine. It's called ONOS. ONOS is a virtual machine within OpenNebula. OpenNebula is virtual machine within OpenNebula itself. And we are using extensively OneFlow to manage the services. And then we have created active interface, which you see up in the left-hand corner, which is the one that allows us to connect to the current BSS and OSS. One of the things that we have achieved is to compress the OSS layer. Those of you that are kind of familiar with the telco environment, the OSS layer is everything that activates and controls the network. We have managed it because since we're building a programmable network, the pieces of the network are capable of controlling themselves, and they just working together with the supervisory system and the management system, and not having any layer in between. Things that are new. This is all IPv6. The whole central office is IPv6. It's much simpler, easier, and give us a great flexibility to program the devices that go inside. Then each customer will have his own virtual machine in the central office. This was, right now we're deploying on a beta environment. It was great. We have 10 customers or 15 customers that will start working with the system in September. So when, with our, scale, how does this scale? Well, the next challenge Telefónica España gave us is, they gave us 3 sample central offices, and last Thursday we were throwing some numbers, and each central office will have about 60,000 customers. So we're going to have about 60,000 virtual machines running on each central office, and each one will have access to the different services that we provide, like the caches, or Niji, or whatever service we provide. And we are, these are the applications that control them. So our close forwarding application, that is something that we have developed our own, where we'll have to tend to these thousands of circuits, or virtual machines with circuits, because what we're doing is we're taking your router intelligence and bringing it to the central office. So you control your router from the central office, and you always have access to the latest technologies and the most updated firmware, and then your home equipment just becomes a switch with Wi-Fi capabilities, TV capabilities, but this is what allows us to really provide the end customer the best connectivity and the most updated. The work we have done here, if you are familiar with some of the work being done by other telcos around the world, is that most of the traffic always passes through the virtual router from the customer. With our application close forwarding and taking advantage of some of the network capabilities of OpenNebula, we're able to divert the traffic most of the time directly through the closed fabric and not having to go down to the servers every time to see what to determine what to do with that traffic. Okay, so if we have voice traffic, it doesn't go through the router. If we have TV traffic, it doesn't go through the router. If ONOS, if we detect that the traffic is an elephant traffic or a long-lasting traffic, then ONOS changes the routing of the traffic, the trace, and it traces it up and goes directly out. We have spent a lot of effort and a lot of international, R&D time on coming up with the right algorithms. We're working together with the switch equipment manufacturers to make sure that we can achieve that. And we're right now it's in production. We're testing it to see what will be the highest amount of paths that we can put through the closed fabric. But that is it's moving fairly well, and I don't think we don't have much problem. And you can see there we have OpenFlow, which is the main component or the main protocol that allows us to separate the control plane from the data plane. This is another thing that we did. This is the first unit that we have deployed in a central office. It tends about 3,000 customers. It's quite small. First thing you can see there, it's 100% OCP. There is no brand equipment here. There's no Dells, no HPs, no Junipers, no Ciscos. It's all white label equipment. We used Facebook's OCP specifications, and we bought the equipment as you see it right there. This changed your mindset a little bit because you have to specify in detail what you need, how is it going to be cabled, what size of CPUs we're going to use, what type of memory you're going to use. And things that we did, first time done anywhere. The whole rack is powered with 48 volts DC. In the central offices we have plenty of 48 volts DC and plenty of batteries to back it up. So the whole rack is 48 volts DC. This is a 48 volt to 12 volts converter. First unit really that went in production around the world. It was quite difficult to get a manufacturer to build one for us, but finally we achieved that. The OLT, that the point of connection to the network, is that orange blade that you see there. The thing is that this is a GPON blade, and we're quickly moving to the next technology, XGS-PON and NG-PON2. For those of you that are not familiar with GPON, GPON is about is a non-symmetrical network termination unit, 2.5 gigabytes downstream, 1.5 gigabytes upstream. We're moving to the next generation, XGS-PON. Actually, this week we're receiving the first unit, and that's 1010, and then NG-PON2 will come later. So we are putting mobile network speed to our traditional legacy network. This is kind of the wiring diagram of the units. We have two banks of 3 servers for now on this first deployment unit, and we have a closed fabric that would allow us to grow horizontally without having to change the configuration of the topology of the network. This is very important because as we don't know how much the central office will grow as new products and services become available, and we have to put more computing capabilities into the central office, this will allow us to grow horizontally, as I said, and it's something that Facebook and Microsoft and Google and Amazon are using extensively. This was, again, explaining, before I mentioned that it takes 48 months to go from one generation of equipment in the telco environment from one to the next. Well, here, 2016, OLTG PON, 2017, XGS PON, and first quarter of 2018, NG PON 2. The separation of the data plane from the control plane, it allows us to do this kind of technology jumps. Right now we have 40G switches. Pretty soon we're moving to 50, 100G GBPS switches, and this is how we're evolving. We're changing the mindset of our company. Where we are at right now, well, we started with the help of Ruben and Jaime. In May of last year, we started this endeavor. We didn't think we were going to get there. Somebody believed that the research work we had done, it was worth putting some money behind it, so they fund us. In July 2016, we finished the ideation phase, and we proved that SDN, cloud, and virtualization could work together. We did a prototyping from July to April. Again, that stage gate was successful, so now they give us more money and more challenges, of course. And now, in September, right now we're looking for the first customers that really want to be part of this pilot. It's quite difficult because we have the network is already in place. So you have to find a customer out of each branch, and each branch tends 64 customers. So we have to find an empty branch, peel it out, and send it through our rack. And then, if we are successful, which we will be, in 2018, we will be trying to set up an organization that helps us bring all this together. Little things about money and this, our controllers love this part. This is for them. This is what the expectations we have. But we have people that look at the numbers, massage them, make sure that the use case works and the business case is okay. And we come up with these numbers, and it looks great. And that was all. I would like to thank, as I said, the OpenNebula team. Without them, it wouldn't been a reality. The other option was the word that was mentioned before, that open something. And we were really scared that if we go that way, we will never get to show anything working. And in a telco environment with real customers, you must always show a product that it is working and performing. Also, I'd like to mention my daughter is here. It's a long time I haven't seen her, and she's really an inspiration.
Okay, thanks, Alfonso.